Photoelectric effect. The phenomena of ejection of electrons from the surface of a metal when a light of suitable frequency strikes on it is called as photoelectric effect. For example, if you consider this is a surface of metal, when light falls on the surface, from the surface of the metal electrons are ejected. So this is called as photoelectric effect. So here whatever the light is falling on the metal surface, it is having some frequency which is represented with nu. Nu is nothing but frequency. At the same time, metal is also having some frequency. That frequency is called as nu naught. This is threshold frequency. Metal frequency is called as threshold frequency. Now, whatever the emitted electrons are there, they are called as photoelectrons. So, generally metals like cesium, rubidium, potassium exhibits photoelectric effect. Here, photoelectric effect takes place only when nu is greater than nu naught. That means incident light frequency is greater than threshold frequency, the electron is ejected from the surface of the metal. When nu is equals to nu naught also, ejection of electron takes place. But when nu is less than nu naught, no ejection of electron takes place. So here nu is nothing but incident light frequency, whereas nu naught is threshold frequency of the metal. The relation is given here. And at the same time, if you see here, one more point also we can add, that is kinetic energy of electrons is directly proportional to frequency of the metal or frequency of incident light, not metal, incident light. Whereas number of particles ejected or number of electrons ejected is directly proportional to intensity of the light. Intensity of the light. Next, from this we can derive an equation which is E is equals to W naught plus kinetic energy. From this, kinetic energy can be calculated. So let us see, E is equals to W naught plus Ke, where W naught is work function which is equals to h nu naught, whereas E is nothing but energy. So according to Planck's quantum, E is equals to h nu. So that h nu I substituted here. H nu is equals to h nu naught because W naught is equals to h nu naught plus kinetic energy. From this, kinetic energy is equals to h nu minus h nu naught. From this, h you can take common, then h into nu minus nu naught. We can also write this equation like this: kinetic energy is equals to hc by lambda. Why? Because nu is equals to c by lambda, we have a relation. So from that I substituted nu value as c by lambda minus hc by lambda. Again from here hc you can take common, 1 by lambda minus 1 by lambda naught. So this is called as photoelectric effect. Simply, ejection of electrons from the surface of the metal is called as photoelectric effect. Now let us see one problem related to photoelectric effect. Here question is, the threshold frequency of a metal is 1.11 into 10 to the power 16 hertz. Then what is the maximum kinetic energy of the photoelectron produced by applying a light of 15 angstroms on the metal? So in this, first let us see whatever the information is given, that I'll write. Threshold frequency of a metal is given, so which is represented with nu naught, which is equals to 1.11 into 10 to the power 16 hertz. So we know that hertz, 1 hertz is equals to 1 second inverse, 1 second inverse is equals to 1 CPS. Next, kinetic energy of the electron we have to find out, whereas lambda is given that is 15 angstroms and kinetic energy is asking. So let us see how to calculate this. kinetic energy from the given information. First, I'll do one thing. I'll convert angstroms into meters. So 15 into 10 to the power minus 10 meters we can write. Why? Because 1 angstrom is equals to 10 to the power minus 10 meters. Next, the formula is kinetic energy is equals to h nu minus h nu naught. From this, h you can take common, then nu minus nu naught. But in the question, it has given lambda, but in this equation, there is no lambda. But we know that lambda we can calculate from where, mu we can calculate from which equation? C by lambda. Then C is nothing but velocity of light, 3 into 10 to the power 10 centimeter per second. So in the meters I'll take this is, that is 3 into 10 to the power 8 meter per second. And by next, what is given, lambda is given in the question, that is 15 angstroms, that is 15 into 10 to the power minus 10 meters. Now meter get cancelled, then this becomes 3 by 15 into 10 to the power 18 second inverse. So this we can write it as 3 ones are 3 5s are 1 by 5 into 10 to the power 18 second inverse. So this we can write it as 0.2 into 10 to the power 18 second inverse. So we can also write this as 2 into 10 to the power 17 second inverse. Now I got new value. Then I'll substitute in this equation. So kinetic energy is equals to, h is nothing but Planck constant, its value is 6.625 into 10 to the power minus 34 joule second, into new value is 2 into 10 to the power 17 second inverse, minus nu naught is given in the question, that is 1.11 into 10 to the power 16 second inverse. 16 second inverse. Now let us see. Kinetic energy is equals to 6.625 into 10 to the power minus 34. So here second inverse, all this get cancelled, into, so 2 I'm writing it as 20 into 10 to the power 16 minus 1.11 into 10 to the power 16. Then kinetic energy is equals to 6.625 into 10 to the power minus 34 into 20 minus 1.11 into 10 to the power 16. So 10 to the power 16 is taken common. Then this is equals to 6.625 into 10 to the power minus 34. This is in joules. Next, into 20 minus 1.11 is nothing but 18.89 into 10 to the power 16. So that is equals to 6.625 into 18.89 into 10 to the power. So here it is minus 34 and here it is plus 16, that is equals to minus 18. This is in joules. So whereas 6.625 into 18.89 is equals to 125.146 into 10 to the power minus 18 joules. So this we can write it as 1.25 into 10 to the power minus 16 joules. So this is the kinetic energy. So I'm considering just 1.25 only. So the answer is 1.25 into 10 to the power 16 joules.